Hello guys, welcome once more to class online. Now if you ever had problem with the equation of wave, equation, because many students might not even know that there's an equation of wave. There's a wave equation at the beginning of wave that you were introduced to. Now this video tackle questions in Jamb Physics 2012, question number 26 to 30, that two questions were asked about the equation of wave, about the wave equation, and they were well explained in this edition. If you don't know too much about it, or you have not even heard about it before, you will get used to it in this video, because we really explain this in a way that it's well explained and clarified, and you will get to learn so much about it in this video. Now don't forget, if you learn something from this video and you want to get more content from us that will better help you understand physics, click on like button. We have lots of content to share with you that will clarify so much for you. Now let's get to number 26 now. The equation of a wave traveling in a horizontal direction is expressed by this equation: y equals 15 sine 2 over 5 root 60 t minus x. What is the wavelength? Now for you to be able to answer this question, you must first of all present the wave equation, and this is the wave equation. General equation of wave is what? A sine 2 pi bracket t over t plus x over lambda, where of course my A is amplitude, my t is time, but this t here is period. Okay, then x it is the displacement. Okay, y x is the horizontal displacement, then lambda is the wavelength. But this question is asking about wavelength. That means I'm looking for lambda. Okay, now if I multiply this 2 pi into this formula, into this bracket, it will become 2 pi will come here, it will become 2 pi t over capital T plus 2 pi will come to the second one, it will become 2 pi x over capital X over lambda. Okay, now it is now well arranged. So this is called the equation, the general equation of wave, general wave equation. This is it, and this is it. Now just take note of it. If I were you, I'll put it down in a book so that I can look at it later and so that I won't forget. Now because I always have a formula book where I look up formulas quickly, so that I can be conversant with them. So this is the general wave equation, and that is it. Now you have to equate this general wave. This is the one that was given to you, that was taught to you in school. Equate it to what you were given in the question. That will become, what I was given in the question is 15 sine 2 over 5 bracket 60 t minus x, right? Now equating it to this one, that will become, what I have here is, it will become, I'm looking for the one that has to do with lambda, that's wavelength. So, and that is the last one here. So I will equate it. That will become, first of all, I multiply in 2 over 5 to each part of this. Multiply in 2 over 5 to each part of this. That will become 2 over 5 times 60t. That will become 2 over 5 times 60t minus 2 over 5 times x. That will become 5 cos 60. That's what 12. 2 times 12 is 24t. 24t minus what? 2 x over 5. Now I have multiplied this 2 over 5 in and simplified it to 24t minus 2x over 5. Now equating lambda, because they say wavelength, and wavelength is lambda. Okay, so I'll now, the ones that have lambda are which part? See, lambda stays with the one that have x over lambda from your natural equation. It is the one that have lambda, that's 2x, 2 pi x over lambda is the one that have lambda. So I will equate this one to the one that have x here. Now that's all you have to do. Equate the one that have x here in your question to the one that have x in the general equation of wave. So I will just say 2x over 5 equals 2 pi x over lambda. 2 pi x over lambda. So I just pick out the ones that are the same. See, two of them, this one and this one have x. They are the same, and the main reason why I'm using them is because they have lambda. This one has lambda, so I must work the one that has lambda, and the way I will work is that I will make them to become equal to each other. So that means I don't need this one, I don't need all these other ones. All I need is the one with wavelength, because I was told to find wavelength. So I will equate them. That will become 2 pi x over lambda, which is wavelength, over equals 2x over 5. And that's what I have here. 2x over 5 equals 2 pi x over lambda. So that then if I cut out the 2 is common and x is common. S will cancel x, 2 cancel x, and 2 cancel 2, x cancel s. I'll be left with 1 over 5 equals pi over lambda. So lambda times 1, if you cross multiply, lambda times 1 is lambda, 5 pi, and that's 5 pi. And if you multiply this one further, you'll be getting 15.7. 5 pi on your calculator is 15.7, and that is the answer. Remember, pi is 20 over 7. So 5 times 20 over 7 is 15.7 meter, and that is your lambda. Now, that is your answer, and that's C. Now, but what you have in C is just 5. Now, when I finished solving this, I looked it up, and what I saw is that I think they might have been, I believe there's a mistake on this. Probably they put a pi in the question, but the real answer to that question is supposed to be 15.7, unless there's a pi in this question that was not typed. And I believe that might be what happened, and that will give you 5. If there's a pi, the pi will cut itself out, which will remain only 5 as your wavelength, and that is the answer for number 26. And let's check out number 27. Number 27 says, from the graph above, if a particle F is at a distance x from O, is at distance x from O, distance x distance from O. Okay. Now the vibration will be different from that at O by what? Now you know that this is horizontal distance, right? This is horizontal distance. Now you can see all the options here are actually factors taken from the equation of wave. They are actually factors taken from the equation of wave. And for anything, I told you that for anything on wave called x means horizontal distance. Now you need to check on your equation of wave for the aspect that has to do with horizontal distance, and this is the equation of wave. A sine 2 pi t over t plus s over lambda, right? Now I said that this x means horizontal distance, while a is what amplitude, while t is time, and then capital T is period. Then I have lambda as wavelength. But you were told x, that means you have to find the aspect that has to do with the horizontal distance, that's x. And that means I will multiply in this 2 pi in, and I will have a sine 2 pi t over capital T plus 2 pi x over capital over lambda. And that's the answer to that question. So the aspect that has to do with x is just 2 pi x over lambda, and that is what you have for your answer. And that makes option A the correct answer. It is all taken from the equation, from the wave equation. It's just the aspect that has to do with the x, which is the horizontal distance. That is x. Okay, the aspect that has to do with x is just the one we are told to pick out from the equation of wave, from the wave equation, and that is 2 pi x over lambda, and that is the answer. A is the answer for number 27. Number 28 says, which of the following factors will affect the velocity of sound? Okay, now we have an increase in the pitch of sound, an increase in the loudness of sound, wind traveling in the same direction of the sound, a change in the atmospheric pressure, constant temperature. Okay, so which of them? Now, for you to be able to answer the question, this is on sound wave. Now, many factors affect the speed of sound. I would have expected them to have put things like temperature. Temperature affect, also medium affect. That sound travel faster in some medium than some medium. Like, okay, now medium can affect. Also, temperature can affect. Sound travel faster in hot temperature. That means in the desert, sound travel faster than in cold temperature. That means the sound you make in the polar region of the world. If you are in the Antarctica region and it is very cold, if you make a sound, it will not travel fast. But if you are in the desert and you make a sound, it will travel faster. So sound travel faster when it is hot than when it is cold. Okay, now, but I will have, those are factors that affect sound. But in the ocean, we were not giving any of those factors. We were giving pitch, loudness, wind traveling in the same direction, change in the atmospheric pressure, constant, and so on. Now, I wasn't expecting this, but you must know something about the formula for the speed of sound. Now, and that formula is velocity is equal to F lambda, and where velocity, V is what velocity, and F is frequency, and lambda is wavelength. Okay, so the factors from this formula, that the factors that will affect the speed of sound are frequency and wavelength. Okay, and but this is for wave, for all wave. Okay, now, but frequency is a function of something among the options. See, now when we talk about pitch, when we talk about pitch, the pitch of a sound is affected by the frequency of the sound. What I mean is that under sound wave, we were taught that pitch is influenced by frequency. That means that the higher the pitch, the higher the frequency, or the higher the frequency, the higher the pitch. So what determines the pitch of a sound is the frequency of the sound, and that is it. So since frequency affects pitch, that means pitch affects the speed of sound, and that means pitch is the answer to that to that question. Pitch is the answer to that question, because from this formula, we saw that the speed of sound is affected by frequency and wavelength. Okay, and frequency affects pitch. That's why pitch will therefore affect the speed of sound, and that is the answer for number 28. An increase in the pitch of sound is affected by the frequency of the sound. Number 29 says the characteristic of vibration that determines the intensity is the what? Now, what affects the intensity of vibration? Is it frequency, overtone, wavelength, or amplitude? Now, this is under sound wave also. Now, what determines the intensity? Intensity is one of the characteristics of sound wave. Now, is it frequency or overtone or wavelength or amplitude? Now, we learned before that pitch is affected by frequency, right? But loudness is by amplitude, and also intensity of sound is by amplitude. So this is a drummer. Let me call him Danibo. He is drumming. Now the intensity means now you can see the way he is drumming. He is very serious with the drum. He is really into this drumming. But what will determine the intensity? It is the amplitude, and amplitude is the distance of movement of his hand from away from the drum. Like, what I mean is that if he's drumming, if he wants to intensify that drumming, he has to move his hand higher. The higher the hand goes, the more the intensity of strike. So if you want to have higher intensity, lift up your hand higher, then hit it higher. So the more you hit it, the more the amplitude. So actually, amplitude means distance away from the drum that he lifts his hand. The distance he moves his hand before striking the drum is the amplitude, and that will affect the intensity of drumming, and that is the answer to the question. So intensity is affected by amplitude, but if they've asked for pitch, it will be frequency. Okay, while frequency is the amount of oscillation on the drum that it makes in 1 second, and that is it. Then loudness is also affected by amplitude. So both loudness and intensity are affected by amplitude, and that is the answer for that question. And that is the answer for number 29. The answer was D. Number 10 says, where can a man place his face to get an enlarged image when using a concave mirror to shave? Now, we know concave mirror produce different kind of image. Some of them are diminished, some of them are magnified, some of them are, and the word enlarged means magnified. That's a bigger image. Okay, now, but on a concave mirror, we know that under mirror we were taught different positions of what objects, different object position and different images that will be formed by their positions. Okay, now we know that there are some on the mirror we can place, if we place the object behind the curvature C, it will form a smaller image. But you know, majorly a large image is formed, okay, when you place the object in between the focus and the lens, okay, and the concave mirror. In between the focus and the focus and the lens, you will get a magnified image. So if you want to get, what I'm saying is that if you want to get a bigger image on a concave mirror, you have to place the object in between the F and the lens, and that will give you the a magnified image. And that is the place. Now if you have placed it at the back of C, you have gotten a diminished image. But if it is between F and the lens, you will get a bigger image, and that is where the pencil should be placed for you to get a bigger image. And that is the answer for number 30. It has to be between the principal focus and the pole, and that is the answer for number 30. And that brings us to the end of this edition. Don't forget that if you want to get more content from us that will better help you understand physics, click on the like button. We have lots of content to share with you that will clarify so much. Until we see you guys, take care of yourself and bye for now.